Alright, welcome back, guys. So on the previous video, we briefly introduced the concept of limits at infinity and the infinite limits through this example of 1 over x minus 1. Now we're going to start with the given graph. So to be able to construct a function for this graph is not easy, but we don't need to do that in this case. We're just going to refer to the graph and answer the following limits questions. So this is our f of x here. So this is our graph f of x, and that's just all these parts here. Part A, we asked to find the limit of this function. What's the behavior of the y value as x approaching 1 from the left side? So here's 1. Actually, I want to do -1, sorry. So I want to do -1, approaching -1 from the left side. Okay, so here's -1 for x, right? And we want to observe, we want to see, okay, as x get closer to -1 from the left-hand side, what is the y values doing? It's actually increasing to positive infinity, okay? So that's going to be positive infinity, all right? Part B, let's look at limit as x approaches -1 from the right-hand side of f of x. Okay, so we're going to look at as x approaches -1 from the right-hand side, get closer to -1, the y value are decreasing to -infinity. Okay. All right. So if this is the case here, we can conclude that the limit overall of the function f of x as x approaches -1. Okay. So this can be does not exist. Why? Because both left and right side limit are not equal. So this is using the concept from lesson 2.1, right? We can do another one here as well. So you can see here, as we let x tend to positive infinity, as input value go to positive infinity, the outputs or the y values are approaching certain number here. So I'm going to say that is -1. So it's going to be part D. Limit of f of x as x go to positive infinity is going to be -1. Okay. All right. So we can answer that question there. So the as far as limit at infinity, it's either equal to number or it's equal to positive or negative infinity. We don't have to consider left and right side limit. The only time we consider left and right side limit if we're looking at the limit at a particular value of x. So by approaching certain value c. If we're looking at a case where just approaching infinity, we don't have to worry about left and right side limit. Okay. Another thing that comes up too as well is suppose we're given a function, something like this here. Okay. And we ask you to see, okay, without knowing the graph, without graphing this and figure out what the limit will look like, how can we determine what the y values, what the f of x values are approaching if we let x tend to infinity? Okay, so an A is asking for what is the limit of this function f of x as x limit of f of x as x approaches positive infinity. What is the value we're approaching without knowing what the graph look like, right? So one way we can do is we can sit here and plug in a bunch of number for x and see what the y value is doing, right? We can pick large value. So when x approaches infinity, we can do like 1,000 for x, 10,000 for x, maybe 1,000,000 for x, and see what the y value is doing, right? We can crank this into a calculator and see what it's doing. So I'm going to go ahead and do that really quick. So 4 times 1,000 minus 4 divided by 3 times 1,000 plus 7. So it looks like, so we get 1.32889 for that one. But you know, this is okay for a problem for a function that doesn't have any exponent, right? It just power 1 there. But what if something like this? Do we want to sit there and plug numbers, you know, into something to the 4th power, right? It's going to become very tedious to do this and complicated. So there's got to be a much easier way to do this, right? And luckily for us, there is an easy way. By the way, this is just, I'm just going to let you feel in that part there. So there are these rules for finding limits for a rational function. So what we're going to do here is we're going to say, rules for finding limit at infinity for rational function. And rational functions are just function consists of 2 polynomial divided like this, right? So that's the rule. Okay. So it says that if we're looking at the degree of the polynomial, okay, degree of the numerator polynomial is same as degree of denominator poly, then the limit as x approaches infinity of this function here is just going to be the ratio of the leading coefficient. Okay, so what that's saying that since in part A the degree are the same for the degree for numerator and denominator polynomial, so you know, we can plug a bunch of numbers in and see what it tends to, or we can say, okay, now using the rule, we can say that the limit of this polynomial or this rational function is going to be 4/3. It's going to be that ratio, 4/3. Okay. This become very useful because in part B there, again, I really don't want to plug all this number into the 4th power, the 5th power, and crank it out over and over again until I see a pattern. It's going to be tough. So in part B, we're going to use this rule, right? So we say if the degree, and I'm going to shorthand this, numerator, in this case is less than the degree of denominator. So bottom, let's do top and bottom, easier for us. So degree top is less than degree bottom, then limit at infinity of the function is going to be 0. Okay, so what this is saying that if we were to do this, plug in numbers and raise it to the 4th power, raise to the 2nd, subtract this, and raise to the 5th power, the 5th power will outgrow the numerator quite a bit in the far long run, and this ratio, this fraction here will tend to 0. That's what it's saying. So in part B, you know, the limit as x go to infinity of this 7x to the 4th minus 14x squared and 6x to the 5th plus 3, this limit is going to be 0. Okay, because why? Because of this rule here. Okay, all right. So there's one more rule, and you kind of guess already the last one. If we have the degree of the top is greater than the degree of bottom, okay, then the limit of the function, of the rational function, is going to be infinity. Okay, I'll let you guys work that out in the homework. But feel free to ask questions during Zoom, and we can do more example. I don't want to do an hour-long video, so a bunch of example, but this should be enough for you to get started on the homework.